Good afternoon, everybody. Welcome to our webinar. So it's a lunch and learn with Craig White from Agile Homes. So we'll be having a lengthy chat with Craig, and he'll be walking and talking us through some of his incredible work over the years and bringing us up to speed with his approach and his ideas and things like the Radical Housing Conference. So it's going to be a really interesting hour. Thank you so much for joining us. I'm just going to show a few slides just to bring you up to speed. Why are we looking at low carbon? Well, of course, concrete is the second most used substance on the planet behind water. It's rather big numbers when we look at just how much CO2 is being released by our concrete use every year. So if we can reduce our concrete use, if we can use clever design and clever techniques to reduce our concrete, our reliance on concrete, then it can only be a good thing, because we need concrete at the end of the day to enable more bio-based buildings, more bio-based products. So we need to use it wisely and in smaller quantities. So anything we can do to help that is a step in the right direction. And there's a little reminder here that foundations and ground floors is about 30% of your embodied carbon for your whole building. So a massive chunk is there in the foundations and the ground floors. So so that's sort of why we're looking at these concepts. So we're going to learn about Agile properties and their focuses and their look at their focus on social value. So Craig has been doing some amazing work looking at working with prisoners and so lots to tell there. We're going to talk a little bit about biogenic carbon and of course modular construction and what that means, and then have a bit of a deep dive into one of their most recent projects, which is Wolverley School Sports Pavilion. All right, so I've set the scene. So welcome everybody. Thanks ever so much for joining us for this lunch and learn session. So my name is Simon Corbey. I'm CEO at the Alliance for Sustainable Building Products. So we are a not-for-profit organisation. It says that in our Articles of Association, and we are mission-led. So we're not a trade association by any stretch of the imagination. We're a sustainability organisation, and this is our mission. So it's to accelerate the transformation to a healthy and low-carbon built environment. And what we aim to do is championing the use of demonstrably sustainable building products, and it's that demonstrably bit that is all important. So we have these pillars, and it's a reminder really that okay, we talk a lot on carbon, but it's also the health and well-being aspects of things, the biophilic benefits of using bio-based products, plus also the social value, of course, which is really important. And then, of course, we've got to think about the technical performance and then the ethical side of things and the sourcing side of things too. So it's a reminder really that it is a big picture that we're considering here. So we're a busy organization. We do lots of research projects. So I have been researching biogenic carbon as a greenhouse gas removal mechanism. We're in this strange place where we don't really know how to recognize and reward the carbon that's stored in bio-based products. So there's a very detailed report that's going to be launching tomorrow. So keep an eye on our website for that. That's working with Gary Newman and Morwenna Spear. So Gary at Wood Knowledge Wales. So yeah, lots of different research projects on the go at any one time, looking at steel reuse, and we've been looking at biodiversity and working with Bath University on how we can use natural materials in our retrofits. We also have got a few specialist working groups, so we bring together all the organisations involved in this area and try and sort of demystify, debunk common myths, and offer sort of solutions, I suppose, to complex problems. So we've got a reducing plastics in construction group. We've got a paints and finishes group, natural fibre installation group, and we just started the other day looking at lime. So all of these resources are free on our website to catch up, and you can watch them whenever you want. So we're up to 163 members, I think, now. So growing and heading in the right direction. We've got lots of good guidance and toolkits, etc. We do loads of events, so we'll talk about one or two of those that are coming up. But do sign up to our free newsletter. We won't bombard you with emails. We're pretty targeted, really. So our next event, which is an in-person event, is in Manchester. So this is part of our Reuse Now campaign, and we've been working with the Institute of Demolition Engineers and the National Federation of Demolition Contractors. The theory being that if we are going to really evolve into a circular economy, then we really need to involve the guys who are bringing down our buildings alongside the designers who are designing our buildings. So this is how we try and shift from demolition to deconstruction, and how we can include and encourage large-scale reuse, of course, which is a huge, great carbon saving. So do sign up for this event. In-person event should be a really lively discussion. The detail and logging in is on our website. I'll be at Woodbuild, which is next week. So that's in Llandudno in North Wales. So working with Wood Knowledge Wales, and looking forward to seeing lots of colleagues and friends there. So hope you can join us for that. Then we're partnering with a new exhibition, which is in Leeds on the 18th and 19th of June. Yeah, have a look at that. And then I'm pleased to say that we've joined forces with the Passive House Trust this year to launch our awards. And we're celebrating 20 years of the Sustainable Development Foundation, which gave birth to both the Alliance of Sustainable Building Products and Passive House Trust. So do come along to that. All the details are there on our website. Should be a really fun-packed afternoon. So just a quick one on the webinar. So we are recording, so please put your questions into the Q&A. Don't use the chat unless you've got a technical problem. You can upvote people's questions in the chat, and we'll take in the Q&A rather, and we'll take them, from whoever's been upvoted the highest, and we'll do it like that. Please don't raise your hand because we're not really monitoring that. If we have time, we'll unmute you and ask you to speak. My colleague Richard is in the driving seat behind us. If you've got any problems, just pop a message in the chat to him. All right, smashing. Well, that's the end of my slides. I'm going to stop sharing. I'm going to welcome Craig to our virtual stage and ask Craig to share a few slides and talk us through what he's been up to, and we'll take it from there. So over to you, Craig.
Great. Thank you very much, Simon. Hello, everyone. I can't see you, but I can imagine a room. And my name is Craig White. I'm CEO of Agile Homes. We design, we make and deliver low carbon affordable homes for people in housing need. So design, make and deliver means we are the designers of our schemes and our build systems. The make is we manufacture low carbon prefabricated or modern methods of construction, as everybody would like to style it today. We manufacture that, and then the delivery is we also take on the role of the main contractor. So we kind of embrace all of that. And the key aspect is low carbon affordable homes for people in housing need. And just before I go into the presentation, an affordable home is an oxymoron. It doesn't exist today. The current method, the current commercial method of delivering houses is really good for making money, and so I don't take anything away from that. But getting that money-making machine to deliver affordable homes, all that does for the money making is make less. So it's motivated to not to want to deliver affordable homes. So we have to build another model. And while my talk is more about how we decarbonize foundation design and also not just the foundations, but the decarbonization of everything we do. Um, I'll explain a little bit about our work, and I will now share my screen
Thank you, Craig.
and go into the presentation proper. So you should now see
Yeah, that's
a
looking good.
picture of a TAM. So this is where we started. So, but just to, as Simon has done, we run something called the Radical Housing Conference, and some of you may have attended either online or in person. We've done 5 of these now. This year we're doing Radical Housing Scotland parts 1, 2, and 3. We've done 1 and 2, and we've got 3 on the 11th of Edinburgh as part of the Architectural Fringe there. Uh, we won alongside another entry, the Esme Fairbairn Foundation award for how we might rethink the delivery of homes using agroforestry. But I just wanted to say that because they have helped sponsor the Radical Housing Conference. So if we just zoom all the way out, this is a slide that came out at the back end of 2020 that now shows that we as a species, in building the shelter we need, building the built environment, that now outweighs all of the natural bio-based environment. So we are creating a huge volume of materials to provide us with the places and spaces we need. And that's kind of made up of metals, asphalt, bricks, concrete. And as Simon said earlier, concrete now accounts for 9% of global emissions. And the stats are varying slightly, but I'll use the lower stat. At the moment, concrete is not essentially a high carbon intensity material. It's reasonably low. The Portland cement has a high CO2 by itself, but when it combined with cement, actually the aggregation of that means it's fairly low carbon. But the problem is we pour 1 cubic meter per person annually on the planet, and that's 8 billion cubic meters, enough to cover the ocean and the landmass of the world with a 2 millimeter thick layer of concrete. So I'm
Mm.
not anti-concrete, I just think we should be using less. So here's a picture of the sort of homes we do. We do one we call Trojan because it's movable. We call that TAM. I'll explain some of that in a minute. So everything under the word movable is movable. Well, then we also do stacking, but in a slightly different way to the kind of volumetric guys uh, or the shipping container principle of stacking. We create shelving and then we put our homes on the shelf. And that's because we want to kind of not create a housing solution that locks people into a tube, but actually creates a space standard normal width living and bedroom spaces. Then we do family homes using exactly the same build system. And then we do mid-rise as well. Mid-rise is new for us, and that is a different method of prefabrication where a frame will also participate in that. So Simon asked me to go back, and I'm now going back to last century. So I was fortunate to be part of the Field and Clegg Bradley team, and I was the project architect alongside Bill Gething and Peter Clegg on the building research establishment Energy Efficient Office of the Future. We handed that over in 1992, so I think we're in the future now. I don't know
Mm.
how energy efficient it is compared to the standards we would be doing, but it was certainly way ahead of its time. And it was also one of the first projects in the country to start looking at carbon footprinting. It was very early days. There wasn't a lot of data, whereas there is much more data today. And what we were able to look at was the use of concrete in the round, not just in the foundations. So this is certainly Europe's first uh, it uses cement replacement. Today, that's what everybody should be doing. So cement replacement was innovative then, but also even more innovative was that it was made entirely out of recycled aggregates that were coming out of an office building in somewhere in the city of London that was being taken down by a giant dinosaur machine, crushed on site, and then delivered to our concrete subcontractor, where they then batch that into cement replacements and recycled aggregates. And it's the first time in load-bearing uh, floors that recycled aggregates have been used. And as far as I know, that was the last time that had been
Mm.
done. And if anybody wants to tell me actually recycled aggregates in spanning floor decks. So that's kind of where I started to go, okay, embodied carbon is going to be part of my working career. I was much younger then, of course. Then we were fortunate enough, as I used to run the architectural practice called White Design, and we did the BRE Innovation Park, one of the projects there. And this is working with Wilmot Dixon, who we did a lot of work with and still have a very powerful relationship with today. And they came to me and said, look, we're going to fund this project at the BRE Innovation Park, and we want to innovate. So this is sort of 17 years ago now, so not last century, early this century. And so effectively, this is well, it's not effectively, it is a cross-laminated timber superstructure, then sitting on screw piles. In this case, it was screw piles. So, and that was because the BRE site had a spaghetti junction of services underneath this ground, and they were very anxious that we would go and any of the projects would be hitting some of their very highly serviced utility infrastructure below ground. So, one, we wanted to not pour concrete. We didn't want to do trench or concrete slab. We wanted to do a CLT floor. And at that point, then we had to kind of create a platform. And in this stage, we're working on a steel platform, working on ground screws. So there's the steel platform, the table, on top of which we would then build the CLT. And that's the ground screws going in. That then tipped out this. So there's the CLT superstructure going in. And there's Kenneth MacLeod standing next to the director of the BRE, uh, waxing lyrical about the BRE Innovation Park. So that's the building was meant to have a 5-year life. I think it's now 17 years later, and all those buildings are still there. When I say a 5-year life, it was meant to be taken down after 5 years, not that it had a short life. And so this was the ongoing journey where we're now decarbonizing the superstructure and the infrastructure below it. But we're using steel platforms at that point. That building's 3 stories high, so you can actually do it on bigger buildings. If you go up much above 4 to 5 floors, you're into a completely different way of thinking about your engineering in the ground. But you can actually innovate. Then we're moving now forward to 6 years ago, and I took the know-how from White Design as an architectural practice. We'd also set up a prefabrication business about 3 years after White Design called ModCell. That's the prefabrication of straw-based building systems. And of course, we're seeing fantastically all sorts of innovation in prefabricated straw buildings. EcoCacan now got a factory with robots working with straw. And that continues to be part of our journey. But specifically, we're now moving into affordable housing alongside the building. So this is an immovable home. And if it's movable, then you have to think about, so actually, how are we grounding it? What do we put it on in its ground screws we're working with? This is another example. This is Emmaus, the homelessness charity in Bristol. And Jessica, the CEO, was saying that as a high street revenue generating charity, they were having a real challenge because the high street is very busy with charities all trying to do good work. And their revenue model was dropping because they do refurbishment, house emptying, and they also run everything as a social enterprise where the formerly homeless colleagues they're called companions, actually become part of the social enterprise and get themselves back on their feet and involving things. So they wanted to do an Airbnb type model, and they were going to put uh, um, uh, a chalet in the yard. And we said, well, I don't think that'll land, but why don't we build it around this tree? So what we were able to do with ground screws, you can actually work in and around trees because the screws displace the roots, whereas trench foundations cut the roots completely and kill them. Then we went on to do other versions. This is for Torbay Council. This is for emergency and temporary accommodation for young single mothers who have fled domestic abuse. And what we were able to do is unlock some land. And in effect, what we were able to do was get a meanwhile use on this site because we were just lightly putting ground screws in. Then most recently, we've just handed over these homes for Places for People, and they had been working over a year to try and get a planning approval on this site. But you can see it slopes. So the previous designers were just saying, well, we can only build on the flat piece, and that meant they were doing rooms that were 9 square meters and 2 stories high, which is multi-story rabbit hutches, not homes. And so these are 25 square meter studios. And what we were able to do was take that innovation of ground screwing and stilting to create a platform that is entirely built on 100% of the site is sloping. And you'll see a picture of that. And it slopes up to 40 degrees. So there we are. We're building a platform. Now the platform is not steel, it's all glulam. So we've decarbonized that platform. It's wrapped and it's wrapped for fireproofing and protection, but that's actually all glulam. And you can see on the left-hand side, it then interfaces with the ground screw head, and then we're stabilizing the slope. That's what that looks like. And there you can see on the left-hand side how dramatic that slope is. And these are now homes for Places for People on their Living Plus program. And these are for people who have lived experience of rough sleeping, coming off the street with complex drug and alcohol addictions. So sometimes the decarbonisation agenda actually allows you to innovate in how and where you can build your homes. That's just the carbon storage number. Then we've been working with Inventor Cinema using the same thing. And if you are going to create a platform or an area under the building which is ventilated, then you want it to work as well. So decoupling from the ground creates the opportunity to do labyrinth cooling and labyrinth preheating. So what you want to do is, if you are going to decouple like this, you have to scrape the ground down, but you create the opportunity for ventilation. So this is a design for a cinema that has no air conditioning in it at all. It
Wow.
uses heat recovery ventilation plus the labyrinth cooling to maintain the internal temperature and stability. We're just about to go on site for these. These are all designed to go onto screw piles. And then this is the TAM being deployed on meanwhile sites. So effectively, you can see we want to create a stack, but not too high. We want to have homes that are normal in width. And so what we did was copy Ready Player One. Some of you might be young enough to have watched Ready Player One, but this is effectively a bookshelf on top of into which we slot our homes. We call it a TAM shelf, not a bookshelf. This is the Wolverley home that Simon was referring to. This is the largest single-story building we've done, and there you can see all of the ground screws are ready. Then towards the bottom right, you can see the prefabricated. So this is timber and straw. This is a straw insulated building. And what we do is we put in the screw piles. We then tie the heads with timber because at this point we don't need a platform to span and support the panels because the panels can do that by themselves, but we need to tie them together. That's tied with timber. And then, in effect, that there you can see the screw head. That is no thicker. It's actually thinner than the rainwater pipe next to it. So it's like doing buildings with stiletto heels, but not damaging wooden floors. Then this is that TAM I opened up with, and this is, I won't play the video, we won't have time, but this, we deployed that TAM 7 years ago. Bristol City Council said, we've got some regeneration funding for Knoll West, and we're doing a new master plan. We'd like you to move the TAM because that master plan has new stuff happening on that site. So in January, we picked it up, put it on a low loader. So that's AM in the morning, that's PM the same day. Here, it's not going on to ground screws, it's going on to pads. So ground screws will work in most conditions, but if you've got rock immediately below, you cannot screw ground screws into rock. So we switch over to a pad on a very, very small footprint of concrete. And then I know that was a video, you can play that. And then this is the last bit of innovation. We are now making we're now decarbonizing the superstructure again once more. We're working with straw, but this is now working with very thin CLT called 3-ply. And we're also working with, on the left-hand side, carbon plantations who are now who have planted 14,000 Paulownia trees in Suffolk. And Paulownia tree is the fastest growing tree in the world. It has the same density as balsa wood, so it reduces the weight, improves the thermal performance, and we're now manufacturing this in Scotland. And then the last slide, almost the last slide, is that's the chief exec, the tallest guy in the middle of the Forestry Commission, standing in a building entirely made out of UK grown 3-ply, manufactured in Scotland, insulated with straw, and it's a monocoque engineered design. I'm going to talk very briefly, because Simon mentioned it, carbon and social value trading. So what we did in August last year, we did the world's first trade for the storage of carbon in the built environment, then linked to the social value we create by working, as we don't have time to talk about it now, but working with inside prisons, providing skills training and education. We have 6 prisoners released on temporary license as colleagues at our workshop facilities. And the trade, by going down this decarbonisation and storage route, was for £45,000 for a 2-bedroom TAM for a Ukrainian woman refugee in Bristol and her 2 children who are currently in temporary bed and breakfast accommodation. And she will now, we just got planning permission for it now, she will now go into a 2-bedroom home with her 2 children. And that's when I'll stop talking. I think that was just over 20 minutes. Apologies.
That's fantastic. Thank you, Craig. That's a really quick run through. Well, amazing. So yeah, pop your questions into the Q&A for Craig. I'm sure there's a whole host of questions that you'll have there. So do pop those in, and we'll deal with those in turn. So
Yes. And
I'm quite intrigued with your biogenic sort of carbon storage and your social value. So is that something that you've actually monetized? Is that something that you've done that transaction?
yeah, we've so monetizing is a dirty word
Right,
for
all right,
many people.
I
So
take it back.
yes, but actually, in pure capitalist terms, we have monetized the storage of carbon. Plus, the reason why the social impact is so important for us, it's the means
Yeah,
by which we can work with local authorities to reduce land costs. So
right.
they will happily enter into a discussion and a negotiation around land costs if the
Okay.
social impact is high enough. So we bring that together. And then if we've discounted the land by 50% because of the social value, we have a public sector diligenced cash value. So
Mm.
we then take that to the corporate sector and say, how's your offsetting going? How's your ESG going? And then we lock that together. And I am now at least once a week speaking to corporates, and we have a FTSE 100 that wants to participate in that. And we want that's not just for agile homes, it's for anybody working with bio-based materials and in the social impact delivery of housing. Then we think that that's more open. But that's got nothing to do with decarbonizing foundations.
No, no, it hasn't. Yeah, all right. Well, let's so please don't forget to put your questions in the chat, in the Q&A. I beg your pardon, I'm confusing myself. So we've got 11 questions already coming in.
Mhm.
So you can upvote these. So I'm going to start at the top. I've got a question from Niels. Can you see
No.
these, Craig?
Yep, I
Yeah.
can. I can see that question. Hi, Niels. Quite rightly, you're asking about the subfloor void, and it's ensuring that it depends whether. So we do not do pure CLT sitting on top of a void. It's a prefabricated panel which also has its vapor check layers. Uh, Everything that needs to be, so effectively it's a wrapped panel, but nonetheless, if that void is not ventilated, then you run the risk of excessive moisture building up in that space and condensation occurring somewhere within either at the underside or somewhere in between. Vapor check layers will help, but the reality is you just don't want to get there in the first place. And so that's why when we do it, we activate the void, not just from a ventilation, a passive ventilation, but coupling it into the heat recovery ventilation, which is now part of all our world. And we can actually couple that void and use it to pre-cool or preheat seasonally, pre-cool in summer, preheat in winter. And so you just adjust how you do your heat recovery ventilation. And then also in the Inventor Cinema, that is a passive as well as active labyrinth. And the reason why we do the labyrinth is each turn of the labyrinth, you get heat exchange. And that heat exchange is either dumping heat back into the earth or pulling heat up into the air. So it's either preheat or pre-cooling. And labyrinth cooling is not our invention. That's been around for some time.
Yeah. All
If
right.
you
Lovely. So
so
I've
if
been
you
asked
ventilate, you will not get the risk
the
of
issue.
damp.
Yeah. Okay. So I've been asked to read out the questions. So next on my list is which manufacturer supplies the ground screws you have used in these projects?
It varies. There's a company called Stop Digging we work with. There's another one. I think Ground Screws Are Us or some Ground Screws Limited. So what we would do on behalf of our clients is that we would always go and tender out to. So ground screws are the smallest. They actually look like just big versions of that, slightly differently engineered, but they look like screws. And then screw piles, which are more a shaft with a much larger blade on the bottom, and that's the domain of more specialist engineering provision. So two types of screws, ground screws and screw piles. Screw piles for the bigger, heavier projects, ground screws. So other than the BRE project, and then those 18 homes I showed you. I didn't show you ground screws. That will be going in on screw piles because it's 3 stories tall. So it depends on the engineering and the ground that you are connecting with.
So do you have to do a survey of the ground conditions, presumably?
Yes, so we have to do penetration surveys. The because basically we are working blind from the top because what you're not trying to do. So the point is minimal disturbance on the
Yeah.
top. You have to do a scrape, of course, because we need
Yeah.
to get the levels right. But
Yeah.
there's a scrape. But from there on in, we're working blind, so we have to do penetration surveys. That won't pick up everything. So you get something called a refusal. So sometimes it'll screw in and
Uh-huh.
then it'll hit something that we didn't know, and that could be a boulder. And if it's this big, you
Uh-huh.
have to kind of move in
Yeah.
X or Y, and that's why the platform. So it's lovely to imagine the world will always take a screw at plus or minus 2 millimeters. It does not happen. We are
Yeah.
often seeing 150 mil of
Uh-huh.
shift and at worst. And so effectively, it's how you engineer your platform to allow for the screw to come up in a slightly different position. I should keep my hand still, and the screw finds that. So there's quite a lot of innovation in how you do the screw heads. That's
So
that's
would you do your screws and then make your platform, or presumably only
well,
two options
it,
today?
if we had lots of time, yes. But
Yeah,
what we
sure.
need to do
Time is of
is
the
you want
essence.
to screw in and platform immediately.
Yeah, sure.
So there are two interfaces.
Oh,
There's
yeah.
the If there's a stilt, then it's stilt to screw. So there's an interface. You saw the head was quite exotic to allow us to locate. And
Uh,
then once the platform is built, then
uh-huh.
effectively you can just move your buildings around very subtly to get them. If the platform's 30 mil out, then the building, because it's an independent unit, it can also be positioned slightly. So
Yeah,
we have two interfaces where we can deal with tolerance.
fascinating. All right, you've got to be fairly flexible in your approach, literally.
Yeah, and then every now and again you hit something and it has to
Yeah,
move so far, you have to go,
yeah,
okay, we've got to now just
that's
sometimes on the Emmaus pods, there was one where we were kind of almost 40 centimeters.
right.
So we then had to kind of order up a glue lamb that would, so we just had to wait for that glue lamb to arrive, which would pick up the extended piece. So yes, you have to be flexible and adaptable and and hope for the best.
Yeah, I'm optimistic. So
Well,
here, strangely enough,
you know,
you
the UK standard tolerance for slab design, if anybody's a project architect working on site, you will always find that there isn't a slab in the country ever poured to tolerance, ever. I've never had one. So
right,
it's kind of
right,
life.
okay, yeah, that's a good comparison, isn't it? Yeah. So you mentioned Jessica at Emmaus. So Jessica's an old colleague of mine.
Ah,
So I know Jessica well. I was still in touch, and so I've not. I did try and book up the pods in Emmaus, but they were busy. But never mind. But I will. I will one time.
yeah.
But all right. So there's a next one from Matai. It's a bit of a question around the glulam ground floor. So the question is, what's the wrap on the glulam ground floor frame, and do you need to use a special timber species for it?
No, so it's the glue lambs will be fairly typical European white pine. So that and depending on the engineering, there's nothing particularly exotic about the glue lamb. So the wrap is doing two things. Effectively, it's a variant on a vapor check layer. Part of the wrap is just to protect the glue lamb. Uh, if we have any rain, we don't want any standing water on the glue lamb during the construction phase. But it also, we can specify the VCL to have a fire resistance to it. And then the glue lamb is, all glue lambs are always oversized for charring rates anyway. They're always just slightly larger to ensure that if there is somebody doing something below, and then we also, because of thermal bridging, on the panel itself, we use a fire-treated wood fiber insulation. So
Oh,
there's a lot of post
yeah.
Grenfell, quite rightly. The construction industry is generally not to be trusted around the materials and protection and the assembly. So we're
Mm,
seeing a lot of innovation, especially in timber fire protection.
yeah. Okay. Yeah. So was the glue lamp from Buckland Timber? We did a
We've worked with Buckland Timber. We've done a number of projects with Buckland. I can't name a supplier to each project, but we have
no,
done
sure,
stuff
it's
with
fine. Yeah,
Buckland.
yeah,
And then we'll go to whoever can supply.
yeah. Okay, all right, lovely. So I've got a question here from Luke. So he's saying you mentioned that the ground screw system only works up to 4 or 5 stories. So have you got any ideas on how you upscale it to a bigger building, perhaps in the future?
Well, I think so. Our world is housing, so there is a kind of natural limit on the size, but effectively, you look at the Shard in London, that's just a whole pile of piles. So that's pile engineering that goes down 60 or 70 meters below ground, and that's why you spend 6 months just hearing hammering going on. So the limit for us is 3 stories plus a roof because of our panelized build system. So any structurally load-bearing panelized system that is not dependent on a frame, can only do 3 stories plus a roof. So that could be lightweight steel, that could be prefab concrete. If it's the structurally load bearing, and this is because of progressive collapse. And then higher, you go into engineering, you go into a complete, if you're doing offices and stuff like that, that's an engineering domain that we don't enter into. But there is a limit. There is a limit to what a screw, how far a screw will go into the ground before you have so much friction that the torque could actually twist the pile. So, and in effect, that's how they do it on site. They screw down until they get to a certain torque, and then they know they've got it locked. So the screw piles can vary in depth between sort of 3 meters and 12 meters. If
Okay.
at Emmaus, that was the site of an old Victorian groundfill site, really, really poor ground. So some of the piles there, I think, are 9 meters deep.
Wow.
One,
Okay.
one, one of them is just only 3 meters deep. So it's there was just one where it was really soft, and the guys just kept on having to put an extender on, and then it locked.
Uh-huh. Goodness. Okay. All right. Another question from Neil. So he's asking, how do you repair the prefabricated floor sections in case of failure? Would you need to take the walls down as well in order to repair those junctions?
Good question. It depends how you build your system. Our approach is to keep it as simple as we can. Because we prefabricate and build, effectively there is a digital twin. So we do it in 2 ways. You use parametric software, and or we're working with a technician partner company that also uses parametric. So uh, the timbers are always in the place we drew them, because we design them, we make them, and we deliver them. At that point, you know where the chambers are. So in effect, there's a chamber. We know what the buildup is. And in effect, the panels can be repaired in situ. I've had to do that in 2010. We had uh, that enormous rainstorm that blew in and flooded the whole of the south of England. At one point, we were on site with a straw project, uh, and we calculated that we had 17,000 litres of water come off the intermediate slab on 4 points. So 17,000 litres of water per pour off point onto our prefab systems. What we were able to do was repair all of those in situ. We didn't, well, there was only one that needed repair. But you're right, there can become failures where you have a problem. It's more to do with the ground thing. Vertical repairs are not so hard, horizontal repairs a bit more difficult. But in effect, in the very worst case, especially with a ventilated void of some height, we could actually excise a panel and build a panel back into it if the worst came to worst.
Okay. Okay. All right, lovely. Thank you, Craig. Next question from Tony. So he's asking, so the loadings for
Yep.
ground slabs, does he mean ground screws? I'm not sure, but
Right, yeah, probably.
saying,
Yeah.
can it be used for cars or vehicles in a garage?
We hold cars don't impose unbelievable loads. They're surprisingly, if you look at car park design, the loading on that is not crazy.
Okay.
As we move more over to battery, cars are getting a bit more heavier. There are examples, not from my built experience, but there are examples of steel framed car parks that are on piles. They would be screw piles. And in effect, there's a kind of a height that you wouldn't go above because you'll be spending too much money on the engineering, and you flick back to, okay, we need to put in trench foundations. So the principle is uh, clearly there's limits to loading, absolutely. Uh, Effectively, with a screw pile, we're point loading, so it's stiletto engineering, and therefore the loading that's coming down and into that isn't like a slab design where you've got a slab which is bearing on the ground, and then you've got your trenches, and then you've got your pads below that. So there are three levels of load spreading in a conventional slab. But every part of those pads, trenches, and slab will already have 25% more concrete than is actually needed. So, but with the codings and all the switches to Eurocodes, what the net effect of that is that we're probably sizing most of our concrete at 25% over what it needs to be. So even if we were to flip back into the site, the foundations would, the ground conditions to say we do have to put in a concrete foundation of some type, then we would be optimizing on that. And there are people at Bath University who are, doing huge research on how do we as engineers and architects wean ourselves off the volume of concrete we use. And then psychologically, for me, pouring money into the ground seems like a particularly foolish thing for us
Yeah.
all to be doing. And especially on slopes where you're having to do cut and fill, you can end up spending 40% of your total budget just on doing your cut and fill stabilization.
Mm.
Whereas screw piles and stilts, you're not trying to get the ground to do, you're not disturbing the ground, so there's no need for stabilization, not in the same way. The stabilization we have done underneath the building is to prevent runoff. So that is effectively just a geotech layer. And for me, psychologically now, I just, I run the business. So I said, okay, we're not pouring concrete anymore until we have to. And now I kind of wince every time when we say, okay, we're going to have to use some concrete. I'm not anti it. It does. Concrete's amazing. It's brilliant in compression. It's crap in tension. And that's why we have to put so much steel in it again. And so the principle is there is no one bad material. There is bad choices that we might make about the uses of those materials.
Mm.
And as designers and engineers, it's carbon optimization, cost optimization, and system or optimization. That's the manifesto there.
I very much like it. Thank you. All right, I've got a question here from Darien asking, have your buildings that don't have planning permission been challenged?
Ooh, yes. So you read that slide, didn't you? That so uh, so agile. The reason we're called agile is not because we just do it on stilts and screw piles, but it's also the agility of thinking that was required to come up with a better model for getting affordable homes. So the very first one you saw, the opening slide, and the one then the last one where I said we moved it. Uh, that complies with the Caravan Act. It's building regulation compliant, triple glazed, everything you would imagine that needed to be a house, but it's movable. At
Yeah.
that point, in planning legislation terms, they're kind of blinded, not, metaphorically, they can't see caravans because caravans are not a jurisdiction under the planning regulations. There is a separate act called the Caravan Act.
Mm.
So, what we did was in Bristol, we did guerrilla housing. That's how we started. I built that on a site, working with the community, with permission of the community. We paid ground rent for that community, built it, and that opening slide picture, we invited the mayor of Bristol to sleep in it. He at that time we got rid of our mayors now, but he's an executive mayor, so he wrote the checks, and he said, "How on earth have you done this?" And it was asked for forgiveness, not permission.
Uh-huh.
And now what we do is we don't do guerrilla housing anymore because I do not want to have fights with planners ever. What we now do for the movable homes, if it's one, it can go in under something called a certificate of lawfulness, which is effectively you're speaking to the local authority solicitor, not the planners. And we do that fairly regularly. And then excitingly, we're doing for the Halton co-housing group up in Lancashire, They got planning permission for 12 homes, conventional, but the budgets, they just couldn't get it to stack up. So we've converted that planning approval into a Caravan Act site license,
Hmm.
building regulations, mortgageable 2025 future home standards homes, but using the principle of laying caravans out in a different way. The word caravan will spark lots of pictures from the, holiday caravans made out of fiberglass and 20 mil of insulation, all the way up to lodges, which are close to, but never really building regulations compliant. So, the principle, that's where the word agile comes from, in that we saw that was a way of thinking differently about land and getting affordable homes built.
Yeah. Okay. Fantastic. All right. So I've got another question from Neil. So this one's a bit of a, have you calculated the carbon related to your steel structure underneath the houses, including the screws, compared to a low carbon concrete slab? Good question.
Excellent. Yes. So
Uh,
we do whole life carbon and carbon footprinting because quite rightly, I have a dent in my chest where people say, what about, what about, what about, what about, what about? And absolutely, that's fine. So some of the background, I like timber. I was non-exec director at the Timber Research and Development Agency for 10 years. Then I was chair of something called Wood for Good, which is
yeah.
now co-opted into Timber Development UK. So I commissioned, when I was chair of Wood for Good, the world's largest life cycle analysis of all North American and European timber, hardwoods and softwoods. So we commissioned the same LCA analysis team that did the steel and concrete industry, and they did the timber industry because we didn't want anybody to say, well, of course you'd say it's lower. Consequently, we have to do the carbon footprint of everything. So that would include the screws, that would include the plastics, and that would include the foundations screwed. The net is it's lower because what we're doing is that we're putting the load into the ground in a more dispersed way. So we're using, so the total volume of steel is less than the concrete and the mesh that you would put into a slab. It'll vary. The carbon footprint will vary depending on depth and depending on how far we're moving things around. And but this is the point. You have to. We cannot just rely on warm words of it's sustainable because it grows on trees and it's sustainable because we're not pouring concrete. We have to do exactly what you've asked, is what is the carbon footprint? But the win becomes at end of life on the screws.
Yeah.
Because we've actually done this. We have actually moved a building and
Okay.
unscrewed the piles. So
Right.
in on the principle is touch the earth lightly.
Mm.
My view is that if we get that balance right, and concrete's here to stay, there's no doubt about that. We should just be more efficient about it. So, but this methodology can allow you to go, okay, so maybe I can find a better balance on the carbon emissions.
Mm.
And the unscrew is quite powerful. If you've ever had to grub up a slab, it's heavy, dirty, difficult, carbon-intensive work.
And then are those screw piles reusable? So can you
Yes, it depends on their condition once you pull
oh,
them out of the ground, but they are fully galvanized and stuff. But my assumption is, and certainly the steel industry would be saying, of course, working with steel, you have this recycle loop. Harder out of concrete because it's mixed up with, you have to crush concrete to get the steel out of it in the future. So I'm
yeah,
not anti-concrete. I'm just, it's beholden on us to do exactly the calculations that you were asking, are they being done?
right.
Because if I'm trading the carbon storage, the first question I get asked is,
Yeah,
okay, there's a net and a gross. What is the difference between the gross storage and the net position once you have done everything else on your building, done done the utility connections and things like that.
Oh, yeah.
And I'm not, I wouldn't try and convince to say, all right, you should just start immediately doing screw piles and ground screws. It's just one of the options we as designers have in our toolbox to think differently. Um,
We've got a question about costs now. So I think,
Costs
quite, yeah, so ground screws compared to traditional
it's
slab
cheaper.
foundation.
It's,
So,
on a completely flat site, it's probably neutral. On a sloping site, compared to cut and fill and slope stabilization, it's cheaper.
all right. And is that much cheaper or so?
It depends on the project, the site, how
Right.
big but there's a lot of variables, but in effect, uh, from an economic point of view, you deploy assets,
Yeah.
materials, you deploy assets. How efficiently can you deploy those assets? So, at an economic level, if you're using less assets deployed, then there is an efficiency in that. And then, if the site's like this, then it's going to be expensive. 40 degrees, we can do it. It's not the cheapest thing in the world to do, but and then flat. I think eventually the ground screw world will be because they're simple elements. They're installed using lightweight equipment. It's just a little mini digger with a screw attachment on it, and I don't have any cart off site, etc., etc. So for us, we know it makes economic sense. A QS, I would ask a QS to go, okay, give me a comparator between one and the other. And
Yeah.
I'm an architect, so I color in for a living.
Right. Well, I mean, we're nearly at time, so thank you so much. So I've got quite a few people saying, do you need volunteers to come
Oh,
and help you on any of your projects? I've got colleagues from Mike Y asking if that might be something you're interested in. And
yeah.
saying, oh, by the way, Mike Y sell wood fiber insulation. Just a bit of a plug for them. So
we we use wood fiber insulation, so yeah. I mean, I think what the center we call it clicks, the Center for Low and Innovative Carbon Solutions. We have open days. And perhaps I've already offered it to ASBP that if you wanted to do an event hosted at Clicks, we can host 40 people, up to 40 people, and we have space to do that.
where is it, Greg?
And then obviously volunteering, there is a well and long established way of how people get involved, particularly in straw bale, doing volunteering work. We are
Mm.
much more systemized than that, so the touch points for volunteering is less, but I'd love to have a conversation to see how we might make that work.
Yeah, okay. And so how do people, do you have a newsletter? How can they find out more about what you're doing and
Well, so our website is called agile.property. That's it.
okay,
No comms or co's. So you can go to agile.property. In
okay.
there is an email address called inquiries@agile.property. That will inevitably find its way to me.
Yeah,
I could give you my email address now, but I'm going to just hold dry on that for a little bit.
yeah, no
Uh,
worries.
and then, yeah, and then also a good way to make contact is LinkedIn. We post a lot on LinkedIn, and if you said I saw you on the SPP seminar, I'll
Mm.
absolutely connect.
Okay, fantastic. All right, well, we've still got a few questions. I'm afraid we'll have to look at those offline and we'll pop those over to you, Craig.
Okay, fantastic.
We've done pretty well on getting through as many as possible. So thank you everybody for joining us today. It's been a fascinating hour. I hope you've had lunch and you've learned. And I'd like to say a huge thank you to Craig for giving up his time, his very valuable time with us. And yeah, keep in touch, everybody. Get in touch with Craig, and we look forward to hearing about your new projects, sometime soon, Craig.
And become a member of ASBP. There you go.
That'll be lovely. That'll be lovely. Yeah.
Okay.
All right. Thank you so much, everybody. Yeah.
I
Look
didn't
after
see
yourself.
anybody's faces, but you're all beautiful.
It's
Thank
a
you for
bit
coming.
weird, isn't it? I love doing events in person. But
Yeah,
yeah, thanks everybody. It's really fabulous. Thank you very much for joining us, and we'll see you at our next event.
great.
So
Thank
thank you
you.
now.
I've got